Hi everyone. In this tutorial, we will talk about the numerical methods, part 1, and we will be concentrating on the bisection method. So, what are the numerical methods? So, when the analytical methods do not work because of their limitations, then engineers or scientists have to go to the graphical or numerical method. So, it's a indirect way to calculate the answers to your problems. So we will talk about the bisection method. So suppose we have a equation and we want to solve for y. Suppose we have y is equal to f of x. Now if I draw a line, I can see that suppose this is y and this is x, and the equation looks like this. So now as you can see that I need to find this number. So the solution to this, if I want to solve for x, so suppose I want to find f of x is equal to 0 and I want to solve for x. So solve for x means that I need to find a value of x at which y is equal to 0, and this is the place where y is equal to 0. So we need to find this point. So how will we find this point? So if you look carefully, that if I put any value of x above this number, for example, if I have suppose this is x1, so this will be x1, and so this will be x2. So in this case f of x1 will be positive and f of x2 will be negative. So if I want to calculate this point, then my first best approximation will be to have x is equal to x1 plus x2 divided by 2. So I will look and calculate, let me call it f dash x. So I will calculate f of x dash, and then if is positive or negative, I can go from there to the next approximation and see and try to go as close to this point as possible. So this method might not work for every formula or every equation we need to solve, but for some of them it will work if some of value of x give you a negative number and some of the value of x give you a positive number. So let me give you an example. If I have f of x is equal to x cube minus 4x minus 9. So in this case, if I calculate f of 2, that will be equal to negative, and f of 3 will be equal to positive. Now so my first approximation will be that x1 is equal to uh, 1 by 2, 2 plus 3, and that will be equal to 2.5. Now I will calculate f of 2.5, and if I calculate that, it will be equal to negative 3.375. So as you can see, this is way not even close to 0, so we will better do one more approximation, and this is a negative number. So if this is a negative number, what I'll do is I'll take I will approximate x2, that will be equal to 1 by 2 x1 plus 3, and then in that case it will be 2.75. Now again I will solve for f of 2.75, and that will give me 0.7969. so this is more closer to 0 now, but this is a positive number. So now in this case I will go for one more approximation, and what I'll do is I'll say x3 is equal to 1 by 2 x1 plus x2, and that will be equal to 2.625. Now again f of 2.625 will be equal to negative 1.4121, which is a negative number. So if I don't try to go beyond this, so my answer will be most closely to um, x4 is equal to 1 by 2 x2 plus x3, and that will be equal to 2.6875. So that is the closest root we have calculated from this by um partition method, or bisection method. And this is not the exact answer, but this is a way of approximation. So if now you can write also a small computer program which will keep doing this approximation to finally get to the answer. But this is a method which will be best suitable for computational simulation, because you can write a program and say it to keep calculating it until you reach zero, and that way you can solve for your equations. I hope this tutorial will help. Thank you.